Okay, hello friends, welcome to my lecture. This is electrical circuit tutorial. So if you are new for my channel, please try to like, share and subscribe my channel. So here it is, my today's lesson, which is series and parallel circuit. So today I'm going to show you how to find the equivalent resistance for both series and parallel circuits. So here it is, series circuit, a circuit in which two components share one common node. Node means it is a point in which two or more elements are connected. Yes, so for series circuit, two components have what? One common node. Yes, so if we take this as an example, both R1 and R2 share a common node what? As this point, yes. So a series circuit in which it's a circuit in which it shares what? A common node, and the other thing it is two components carry what? The same current. Yes, that means which flows what? The same current through them. So now let me show you how to derive or how to obtain an equivalent resistance for series circuits. Yes, just to find an equivalent resistance for any circuit, it helps us just to find what? Total current flowing through a circuit. So if we have a circuit like this, it can be is as R equivalent. That means an equivalent resistance for a series circuit can be symbolized as like this. So if we have a voltage source here and if we have a current flowing through the circuit like I, so from this, just by using Ohm's law says that with a voltage drop across a resistor, it is directly proportional to a current flowing through what? A resistor. So from this, current can be obtained as what? Obtained as voltage over R equivalent. So obtaining this equivalent resistance help us just to find what? The total current flowing through this circuit easily. So now let's show you how to find or how to derive the equivalent resistance for series circuits. Yes, so if I apply KVL for this circuit, that means a, a sum of a voltage across a closed loop is what? 0. Yes, so if we take KVL for this circuit, we can obtain as what? So if the direction of current is like this, since this current is entering in a negative terminal for an applied voltage V, so it can be what? Minus V, that means input voltage for this circuit, plus V1, since for this resistive element the current is entering in a positive terminal, so it can be signed as what? Positive V1 plus V2 equal with 0. Yes, since a summation of voltage across a loop or a closed loop is equal to what? 0. Yes, so if we rewrite this equation as V1 V or an applied voltage for the circuit equal with what? A voltage drop across the first resistance, that means V1, plus a voltage drop across the second resistance, that means V2. So from Ohm's law, we can obtain the formula for V1 and V2 in terms of what? I1 is, so V1 can be calculated as a voltage drop across a resistor R1. It can be calculated as what? R1 times I. That means a current flowing through this circuit. And V2 can be calculated as I times what? R2. So now we can substitute the value of V2 and V1 in terms of I1. Yes, R2, here it is R2. So V equal with what? Or a total voltage which is applied for this circuit can be V1 can be replaced by I times R1 plus what? I times R2. R2, that means a voltage drop across the second resistance, that means I times R2. So we can use I as a common, and we can have what? R1 plus what? R2. R1 plus what? R2. So if we finding the value of I, this by dividing both sides by R1 plus R2, so we can obtain the formula for I in terms of an applied voltage V and a series resistors that are R1 and R2. So I can be voltage over what? R1 and R2. Now we can just find out the equivalent resistance for this circuit just by relating this equation, yes, and what? This equation. So from this we can find out the equivalent resistance R equivalent was as R equivalent as what? R1 plus R1 plus R2. So yes, so for any series circuit, an equivalent resistance is what? A summation of each individual what? A resistance. So if we have multiple elements here, just we can find out the equivalent resistance for this series circuit just by adding their values. So this is what? How to find an equivalent resistance for series circuit. And here it is, parallel circuit. So as series circuit, a parallel circuit is a circuit in which a component share two common nodes. So as I told you, a node means it's a point in which two or more elements are connected. So as you see this example, this resistor R1 and R2 are connected or share what? Two common nodes. That means node A and what? Node B. And the other thing here it is what? And how what? The same voltage drop across each common or each components. Yes, so we can have the same voltage drop across the first resistance R1 and the second resistance R2. So now let me show you how to derive a formula for finding an equivalent resistance for parallel circuits. So from this, if we apply KCL at node A, that means KCL states that the total current entering to a node equals what? A total current which is leaving from a node. So here it is, we have two currents which is leaving node A, and we have one current which is entering into node A. So we can simply find out I, that means a total current which is flowing through this circuit can be calculated as what? I1 plus I2. Yes, I1 plus I2. So as I told you, parallel circuits is a circuit in which each resistor or each component have had the same voltage drop. So I1 can be what? Calculated as from Ohm's law. I1 can be calculated as what? V. That means an applied voltage for this circuit over what? The first resistance, that means R1. Yes, and I2, that means a current flowing through the second resistance can be calculated as just by using what? R2. So now we have a formula for both current I1 and I2, and I that means a total current which is flowing into the circuit can be, this circuit can be redrawn as like this. So we have an equivalent resistance R equivalent, yes, R equivalent. And we have a voltage source, that means a voltage source which is applied for the circuit, and a current, a total current flowing through the circuit can be I. So from this, just we can find out a formula for what? I, just by using Ohm's law, it can be calculated as V over what? R equivalent. R equivalent. Yes. So you can find out as V from this one. V can be calculated as, that means I times R equivalent. So now, so we can substitute the value of I by this one. So V, yes, V over R equivalent. That means an equivalent resistance for this parallel circuit. So I1 is already obtained as V over R1 plus V over R2. So we can use an applied voltage V as a common. So we can have 1 over R1 plus 1 over R2. So now we can cancel out this voltage by this one. So we have what? 1 over R equivalent equal with what? 1 over R1 plus 1 over R2. So this can be written as what? R2 R1 plus R2 over R1 times R2. That means a product of each resistor. That means R1 times R2. So if we take an inverse both sides, we can just find a formula for an equivalent resistance for parallel circuits. Yes, so if take a reverse, an equivalent can be calculated as R1 times R2 over R1 plus R2. So we can find out an equivalent resistance for parallel circuit just by dividing the product of each resistance over their sums. Yes. So okay, this is how to find a formula or an equivalent resistance for parallel circuits. So here it is an example. It says find the equivalent resistance, that means R equivalent, yes, an equivalent resistance for this circuit shown below. Yes, so we have around 1, 2, 3, 4, 5, 6, and 7, and then we have 8 resistive elements. So the question says find equivalent resistance for what? These 8 elements. So let's start. So let's start evaluating the equivalent resistance from the right side. So as you see, these 4 ohm and 5 ohm are connected seriously because they share what? One common node, and they carry what? The same current is. So the same current flowing through these two resistors. So we can say that these resistors are connected seriously, and 5 and 3 ohms are shared one common node here, and they carry the same current. So we can say that these two resistors are connected seriously. In general, these 3 resistors, that means 4 ohm, 5 ohm, and 3 ohm, are what? Connected seriously. So we can just find out the equivalent resistance for these 3 resistors just by adding what? Their individual values. That means 4 plus 5 plus 3. Yes. So we can have 4 plus 5 plus 3. So it will be what? 4 plus 5, that's 9, plus 3, 12 ohm. So the equivalent resistance for these 3 resistors is 12 ohm. Now, just we can what? Replace these 3 resistors just by what? A single resistive element, that is what? R equivalent 1. That means 12 ohm. Yes, 12 ohm. Yes, now as you see this diagram, these 4 ohm and this 12 ohm are connected parallelly because they share 2 common nodes. That means this node, yes, this node, and what? Actually, this node and this one, yes. Yes, we can cancel out these resistors. So the second are equivalent to yes, these are equivalent to 1, and these form are connected parallelly. So we can find out the equivalent resistance for these resistors just by dividing their products to what? Their sums. So 12 ohm times, that is what? 4 ohm over 12 plus 4, that's what? 16 ohm. That means 1 6. So this can be calculated as 12 times 4 times, it is what? 48. So 48 over 16, that is 3 ohm. And the other thing I would like to tell you is, if you are finding equivalent resistance for parallel circuits, the equivalent resistance are equivalent always less than the resistance of what? Each individual resistors. Yes, so as you see is 3 ohm, which is less than what? 4 ohm and 12 ohm. So now we can have our circuit is reduced as, yes, here it is 3 ohm, and here it is 6 ohm, and here it is what? 1 ohm, and we have 3 ohm here, and our equivalent to that is what? That is 3 ohm. Yes, 3, it is also 3, 6, 1, 2, all are in what? Ohms. So now we can have what? 3 ohm, this resistance 3 ohm, and this are equivalent. That means are equivalent, which is the ohm are what? Connected in seriously, because they share what? Only one common node, and a current flowing through these two resistors what? Is same, yes? So we can have what? R equivalent 3, R equivalent 3 can be calculated as just by adding these two resistors, yes? That means 3 plus 3 plus 3, that is what? 6 ohm. 6 ohm. So now we can replace these two resistors just by what? By a single element, that is what? By this ohm, that is what? 6 ohm. 6 ohm. Now our circuit is furtherly reduced as just we have 1 ohm here, 6 ohm, one, two, all are in ohms and are equivalent 3. That means what? 6, yes? So now we have two parallel resistors here, and they share two common nodes. So we can calculate the equivalent resistance for these resistors just by dividing the product of each resistor by what? Their sums, yes? So at equivalent for can be calculated as just by dividing what? The product to their sums. So 6 times 6, which is what? 36 over what? 6 plus 6, that is 12. So this can be 3 ohm. Yes, now our circuit will have yes, so this is 2 ohm, and here it is 3 ohm, and it is 1 ohm. So now our circuit is reduced like this. So we have 3 elements here, and there is what? A current which is flowing through these resistors is same. So we can say that these all three resistors are connected what? Seriously. So we can find out the final equivalent resistance for the above circuit as just by what? Summing, or just by take a sum of what? This equivalent resistance for 2 ohm and 1 ohm. So we can have 2 plus 1 plus 3 equal with what? 6 ohm. Now you can just calculate a total current which is flowing through this circuit if we have given an applied voltage here. So this is the end of my today's lecture. So please try to like, share and subscribe my channel to get more videos on electrical circuit tutorials. So thank you for watching.